Just some quick background on our company. You may not have heard of us. We've actually been around for a while. We've been in business about 8 years. Our business actually comes out of some requirements that were given to us by essentially some of the intelligence agencies, so the Department of Defense and the NSA. And in the process of solving their challenges, we actually improved network performance in terms of latency and throughput. So this is a ultra secure network technology, but in addition to that, we're improving performance in a variety of different ways. This has been tested and vetted by really some of the best and brightest in the business. So you can see that some very sensitive networks are already being protected by dispersive technologies. So we've learned a lot of things at ONUG already. One thing that people keep harping on is that WebEx is not a really good way to demonstrate changes in latency, changes in video performance, because obviously it's introducing its own set of challenges. So we have a full demo of smooth real-time video on both the traditional VPN as well as our DVN technology over at our booth. We welcome you to come over and take a look at it. We can explain exactly what's happening there. I will explain what the architecture looks like, but really the key here is that this is game-changing technology in that we have pushed the burden to a possible hacker or an interloper by adding lots of obfuscation and subterfuge in order to confuse them and to make our traffic essentially blend in with traffic on the internet. In addition, this technology is generally used as an alternative to MPLS or an alternative to VPN. So there's a large CapEx and OpEx cost that can be achieved. If you're interested, please stop by the booth. We can discuss it. So the major fundamental difference between us and a lot of the other technologies that have been demonstrated so far today and yesterday is that a client session from source to destination generally follows one path. In our architecture, we actually have the clients talk through a transport network. So this is more or less transport as a service. The traffic bounces through what we call deflects. Deflects are IP nodes that sit out on the internet, and all they do is receive and forward traffic. I should note that our solution is entirely software. It can run as a VM, it can run as bare metal, but it is a driver-based solution. So we are transparent to the operating system. Applications do not need to be rewritten or changed in order to take advantage of this technology. I mentioned before that these deflects, so these are VMs or cloud nodes that bounce the traffic. So by scattering these around on the internet or on your WAN, it gives you the ability to find more paths. So we generally find more paths than anybody else, and we intelligently use those paths to optimize the traffic flows. So we have artificial intelligence that's measuring traffic flows and determining what paths we should be using for our low latency traffic as well as our high throughput traffic. At the booth, this is exactly what the infrastructure looks like. So we have a 1080p camera going through one ISP, going to a laptop, showing the video, and the exact same solution, but this time with two ISPs. So the POC challenge was the network connectivity. We have two ISPs here, and as well as 5 deflects. So the traffic is being split in two by the gateway, and is also being physically dispersed across those deflects and then reassembled on the laptop. So as we introduce packet loss and a little bit of latency, you see the VPN performance tank, and ours stays relatively smooth. In addition, what's going on in the background is that the traffic flows are being dynamically moved across from deflect to deflect. So just when you think you know where the traffic is, we've actually moved. That's a security mechanism as well as a performance improvement. Come on. PowerPoint's not my friend today. Sorry. So our dispersion technology is designed really for the most sensitive networks. So we add a lot of really cool features that are, we have a GUI and we have a CLI like everybody else. And these are, you can turn on these really cool features with just checkboxes. So you can add red herring data. So for example, we take your payload and we cut it up into slices and wrap it with bogus data. So if a hacker was able to actually get into the data stream, they wouldn't know where the data begins and ends. Only the source and destination know the exact byte interleaving of the data within that red herring space. The packets are routed independently, so they each get unique encryption and then are routed to a different deflect. Right off the bat, we were adding a lot of encryption because we're splitting a packet or a session into 10 or more pieces. That's just an example. And then we're adding AES 256 unique keys to every single path. I mentioned that we have the data obfuscation technology as well. So this is the really cool thing. This is what kind of has me blown away, that a TCP session is now able to run on many links, many different physical links going across the internet, and we have artificial intelligence that's dynamically steering them across paths with real-time statistics gathering in order to make those determinations. So I'm basically at my time limit here. Please come by and check out the booth, and be sure to look at our demonstration of the VPN versus DVN solution.